Welcome to this introduction video on Blue Demon's ER4043 aluminum welding filler wire. In this video, we will discuss some of the details of this electrode, some safety concerns and how to deal with them, and a short demonstration of the product. ER4043 is one of the oldest and most popular aluminum filler metals for both welding and brazing. It can be used in three processes: gas tungsten arc welding, GTAW, also known as TIG welding, gas metal arc welding, GMAW, also known as MIG welding, finally, oxy-fuel welding, or OFW. One of the first questions you may have about this product: what do the letters and numbers mean? Filler metals are manufactured into different forms and classified into different categories. In our case, the classification is ER, which stands for electrode or rod. Other classifications could include E for electrode, R for rod, or B for brazing, just to name a few. Electrode simply means the filler metal carries the welding current in the process. Adversely, a rod doesn't carry any current and is heated by another source. For the purpose of this video, the number we really want to focus on is in the first position, which in our case is a 4. This digit identifies the primary alloying element of the filler metal. A series 2 would indicate copper, 3 magnesium, 4 silicon, and 5 manganese, just to name a few. The second number identifies specific impurity limits of the wire, and the remaining numbers indicate the minimum amounts of aluminum of the wire. 4043 comes in roll form for use in the MIG process. It is also manufactured in rod form for the TIG process or brazing. When using 4043 in the MIG process, you should have your machine set to DC electrode positive or DC EP. However, when using the rod form of 4043 to TIG weld, you should set your machine to AC. Both the MIG and TIG processes can utilize 100% argon or a mixture of argon and helium as the shielding gas. When brazing with 4043, you are required to provide the flux. Welding positions include flat, vertical, overhead, and horizontal. When selecting aluminum filler metal, it's always best to know the base materials you're welding. In some cases, however, you will not know the materials you have. ER4043 is compatible with several types of aluminum and cast alloys. They include 3003, 3004, 6061, and 6062. Also, cast alloys 355 and 356, just to name a few. 4043 is a very popular choice for welding aluminum. 4043 is a general purpose filler metal that has high ductility and high resistance to cracking during welding. Because of the silicon additive, it has improved fluidity or wetting action during welding. 4043 is used in a wide array of applications. Some of the common uses are in the automotive industry, fab shop work, and heavy-duty trailer manufacturing. Check out Blue Demon's website for more product details and instructions on using ER4043. Let's stop here for just a moment before I begin the demonstration portion. We need to talk about safety. The welding process can produce harmful light, fumes, sparks, and flying slag, just to name a few. You should always wear the proper clothing and safety gear while welding. This includes, but is certainly not limited to, a welding hood, welding jacket or long sleeve shirt, I would suggest cotton or wool, as synthetic materials may melt to your skin. Next, select a proper thickness of gloves, ear protection, and safety glasses. One should always wear eye protection during the welding process. Here's a tip. Many welders will wear a small respirator, like the one seen here. It filters out some of the harmful things floating in the air. The other thing it does is direct the hot air you breathe down and out of your hood. If you've ever welded before, you know the lens can become so fogged you can't see anything. Other safety concerns exist in your shop. You will want your welding area to be free of flammable materials, such as shop rags or paper towels. You should keep flammable or combustible liquids properly stored away from any source of heat or sparks. Because of the high risk of fire, you'll want to keep a fire extinguisher close by. Also, you'll want to check all electrical cords and cables periodically. You don't want any frayed or exposed wires. And finally, you want to make sure all cylinders are secured properly while in use or in storage. Now that we've covered the safety portion, I'll set up a few test coupons and run a few beads. Today, I'll be using Blue Demon's 140 MSTI. This is an inverter style machine that runs on a standard 120 volt outlet. This unit is also called a multi-process welder, which means it can weld using multiple processes. I'm relatively new to welding aluminum, so I want to pass along some helpful tips I've learned. When welding aluminum, it's very important to keep the base material clean as possible. You should even use a stainless steel brush to clean or break up the oxides that form on the outer shell of the aluminum. I've often heard about the 3 C's of welding. However, it was made clear to me that it was extremely important when welding aluminum. With reference to the stainless steel brush, you should keep one that is dedicated totally to aluminum work. This will keep small particles of stainless or carbon steels out of your aluminum weld pool. Preheating your aluminum workpiece will help reduce cracks. Preheating is always possible. However, for smaller parts, you could use a small hot plate. With a smaller welder such as the 140 MSTI, you will want to preheat thicker aluminum. For instance, the parts in this video, I had to preheat somewhat for good penetration. The plate had a thickness of 0.188, nearly 1/4 of an inch. MIG welding carbon steels, you can push or pull your torch. However, when MIG welding aluminum, you should use the push technique. This will help you in 3 ways. As you push the torch, you get better cleaning action to remove oxides. It also reduces weld pool contamination and increases shielding gas coverage. When aluminum welds fail, it is usually due to cracking of some type. When you are finishing up the weld bead, you should take extreme care to fill in the small crater at the end of the weld joint. This can be easily achieved by reversing your travel direction as you reach the end. After you reach the end of the joint, you can simply pause for a moment and then travel back up the bead for approximately 1/2 inch. This should fill any crater. Here's an example of a crater that can be left at the end of a weld bead. If you're going to use aluminum wire without a spool gun, you will want to switch out your steel liner for a plastic or Teflon style. A plastic or Teflon liner will ensure consistent and smooth wire feeding. You also want to check drive rolls for alignment to ensure a smooth transition from roll to liner. The last thing I want to pass along is about stick out. When welding carbon steels, you typically want 1/4 to 3/8 of an inch wire stick out. When welding aluminum, you'll want something around 3/4 of an inch. It is my understanding this will save you from burning up a lot of torch tips. I really appreciate you spending your time with me today, and please remember Blue Demon for all your welding needs. Thanks for stopping by, and I'll see you next time.